We think of artificial intelligence as something weightless, living in a clean, sterile sky we call the cloud. But if you want to see where a ChatGPT prompt actually ends up, you have to look down. Deep under the streets of our quietest suburbs, millions of gallons of scalding, chemical-heavy industrial brine are quietly rushing through municipal sewer pipes. AI has a dirty physical plumbing problem, and it is quietly pushing local wastewater treatment plants to the point of structural and biological collapse. For decades, data centers cooled themselves with simple air conditioning. It was loud and inefficient, but it worked. Today, that is physically impossible. A single modern artificial intelligence server rack now draws up to 100 kilowatts of power, packing the heat of 50 residential stoves into a space no larger than a household refrigerator. To keep these hyperdense silicon chips from melting, tech companies have had to abandon air cooling entirely and turn to massive evaporative cooling systems. These are essentially giant, open-air radiators that swallow millions of gallons of fresh water every day. But that water cannot simply disappear. To understand where this water goes, imagine boiling a giant pot of tap water on your stove. As the water turns to steam, the minerals, calcium, and salts do not evaporate with it. They stay in the pot, getting more and more concentrated. If you keep refilling the pot without washing it, you eventually get a thick, corrosive crust. In a data center, this mineral scale would instantly destroy multi-million-dollar cooling equipment. To prevent this, facilities must constantly bleed off a portion of this highly concentrated, mineral-rich brine. This toxic runoff is called cooling tower blowdown. It is loaded with anti-scaling chemicals, heavy minerals, and toxic biocides used to stop algae growth. And there is only one place for it to go: the local sewer line. This is where our digital world collides with biological reality. Modern municipal sewage plants do not just filter water with metal screens. They rely on billions of living bacteria to eat our organic waste in a process called activated sludge. But these microscopic organisms are incredibly fragile. If the water coming down the sewer pipe is too hot, it cooks them. If it is too salty, it dehydrates and kills them. When a data center dumps millions of gallons of hot, chemical-laden blowdown into a local sewer, it can poison the biological engine of the town's treatment plant. If those bacteria die, untreated human sewage can bypass the treatment process entirely, spilling directly into local rivers and drinking water sources. This is no longer a theoretical threat. In major tech hubs, the strain is reaching a breaking point. Northern Virginia processes an estimated 70% of the world's daily internet traffic. Local wastewater authorities there have had to quietly rewrite their sewer ordinances, setting strict temperature and chemical limits specifically targeted at data centers. In dry climates like Mesa, Arizona, or the plains of Oregon, tech campuses are importing millions of gallons of pristine drinking water, only to return a fraction of it as highly concentrated industrial discharge. Municipal systems designed to handle household waste and light commercial runoff are suddenly being asked to act as industrial chemical treatment facilities. It seems like an easy fix. Why not just stop using water? Tech companies could theoretically switch to closed-loop dry cooling, which acts like a car radiator and discharges zero wastewater. But engineering is defined by brutal trade-offs. If you eliminate water cooling, you must use massive electric chillers and giant fans to move air. This causes the data center's electricity consumption to skyrocket. In a world where the power grid is already buckling under the weight of AI, switching to dry cooling simply swaps a water crisis for an energy crisis. Water is the thermodynamic cheat code that tech companies use to keep their electricity bills low, and the local sewer is the rug they sweep the consequences under. When a municipal sewer system cannot handle the sheer volume and chemical intensity of data center wastewater, someone has to pay for the upgrades. Treatment plants must build specialized pretreatment facilities, install expensive cooling basins, or buy advanced chemical neutralization systems. While some cities levy surcharges on tech companies, these fees rarely cover the long-term wear and tear on concrete sewer pipes, which dissolve faster under highly acidic or mineral-heavy flows. The result is a quiet transfer of wealth. Local taxpayers are unknowingly subsidizing the physical plumbing of the AI revolution through higher water bills and municipal infrastructure bonds. The path forward requires a fundamental shift in how we build the cloud. Tech giants are beginning to realize that the sewer bottleneck could halt their expansion faster than a chip shortage. Some are investing in on-site recycling loops, cleaning their own blowdown water so it can be reused multiple times before it ever leaves the property. Others are experimenting with direct-to-chip liquid cooling, using non-corrosive fluids that never evaporate or leave behind toxic brine. But these systems are incredibly expensive and difficult to retroactively install. Until they become the absolute industry standard, our digital future remains tethered to a fragile, aging network of concrete pipes beneath our feet. The next time you run an AI search, remember, that data does not live in the sky. It leaves a physical trace, and right now, our sewers are struggling to wash it away.